So the only purpose of an assembly language is to provide mnemonic instructions for machine language. There is no attachment of the assembly language instruction to the hardware opcode except inside the assembler. And the only reason we have the mnemonic instructions we do is because they were the ones suggested by Intel. But there are some assemblers that use different mnemonics. One such assembler is AS, the UNIX Assembler. It uses a set of mnemonics, sometimes referred to as the AT&T mnemonics. The assembler is sometimes called the portable assembler, although it's not really entirely portable, but it is close, and it's used in a very portable way. It is the assembly language generated by the GCC compiler in Linux. And after an optimization pass designed for the specific target machine, it can produce object that is executable on any of several different CPUs. Now, C is actually the portable language. It compiles into the portable assembly language with features for the target machine. If nothing else, different machines have a different layout of registers. If you want, you can see what these mnemonics are like. Use the GNU debugger to disassemble a block of code, and it comes back as portable assembly language. The portable assembly language has some distinctive characteristics. For example, it follows the Unix tradition of being in lower case. It is required that all register names, labels, opcodes, whatever, be written in lower case. And you can always recognize a register name because they all begin with a percent sign, where in NASM you would write EBX. In the portable assembler, it would be %EBX. Every mnemonic includes a linked specification, B, L, or W. For example, in NASM you would write this instruction, and by implication from the size of the registers, the assembler would know that this is a word, a 16-bit operation. The portable assembly language would require that the instruction include a W to signify the length. Every immediate value in an instruction begins with a $sign. If you want to push a 32-bit constant on the stack in NASM, you would write this instruction. For the portable assembler, the length is this instruction, and the constant value is preceded by a $sign. Because certain instructions exist only in the Intel chip, and the GCC compiler never generates them, they are not included in the assembler. In particular, the conditional loop instructions are simply not included. There are some other differences, but they're mostly minor. If you want to see the differences, I would suggest writing some assembly language, assembling it with NASM, and then disassemble it with GDB.